Hi, my name is Elena Moore. I'm going to be talking about the phylogenetic tree I made. And just to start off, my sources for this video were number 54, video number 54, and the problem session for phylogenetics. So first I did shoes, and I picked out the first shoe that is known, which is Fort Rock sandals, and then that kind of evolved onto itself to become the sandals we know now. And down here we have closed-toed and open-toed or partially open-toed shoes with the Crocs. So I put Crocs with wedges and flip-flops, but I put wedges and flip-flops on a shorter distance because I felt like those kind of related to each other more. And then we also have heels that kind of relate to the wedges more than anything else, so that is also why I did that. And then down here I have boots and short boots, and then sneakers and athletic shoes for shorter closed-toed shoes, and then the taller. So talking about some topics, we have anagenesis, which is where, like I said, like the sandals kind of evolved on top of each other to be the sandal we know now, but they're still sandals when they were in the beginning as well. And then cladogenesis, so that's anagenesis, where it kind of stays the same but continues to evolve as a species. And then cladogenesis is where a branch branches out into two other branches at a time. So you can see we have that a lot. And then that is also inside of the phylogenetic tree. We have internal nodes, which kind of can show the cladogenesis as they branch out. So I have those highlighted. And then this is an out-group rooted tree because it kind of has to depend on the out-group for the rest, how the rest looks. So if there wasn't an out-group and it was kind of like the other one, it would be different. But see, this one is kind of based on the out-group that we have as sandals. And then talking about OTPs and the distance between all of these, normally you would have, or OTUs, sorry, which are operational taxonomic units. And then that is where RNA is similar enough, like 97%, to count as a similarity in the DNA and the RNA. So you can kind of compare and see which ones are more similar and get it down to a smaller level than just what we have here. So that's what that would show. And it kind of, the lines do show that. And so like the wedges are closer to the flip-flops than the heels, and the heels are closer to the wedges and the flip-flops, and you can see that by the lines kind of represent the distance.